Okay, so as always, the Codeforces question will be in the description, but if you want the explanation, you can continue watching this video. See, this question is actually easy, as I keep saying in every video, and I'll explain why. But before that, let me explain you the question. See, they will basically give you two coordinates. One coordinate consisting of x and y. The next thing they'll give you is the radius, which basically means they're given you a circle with its coordinates on the coordinate axis and its radius. The next thing is they'll give you another coordinates too, x dash and y dash. And you have to make sure that you bring this circle here. This is the same circle actually. This and this is the same circle. Your job is to bring this from here to here. How? See, the thing is, we have an operation that we can make. And the operation consists of taking some point here, some point that you want, any point. For example, if you take this point, this is a point. Now you pivoted, take it as a screw. Like you take in a screw here, you put a screw there. You can move the circle, taking this as a reference screw, and you can rotate it at any angle, 180 degrees, 360 degrees, your wish. And then you can, that final position wherever you leave it, wherever angle you leave it after pinning it here will be the final position, and it will count as one move. You have to make the minimum number of moves such that it reaches this point. This circle comes here with the point being x dash and y dash. Okay, so this is the question. Now, before you get confused as to how you are going to do this thing, let me tell you, as always, that if you want to solve a question, you have to boil it down to its most individual component. The question they gave you is one thing. That's a Codeforces question they gave you. But what you're actually supposed to solve here is something that you'll boil down and you'll find out what you're actually supposed to do, not what they're asking. Because if you boil it down, there are two different questions. So what you're supposed to do is basically, first things first, this point should come here. You have this operation to do it. Now you can make it such that in this operation, you can rotate it by 180 degrees, right? This means that if, for example, if you rotate it by 180 degrees, you'll get this circle. So this is the point. The distance between these two will be 2r. So first things first, your first point should be, okay, let's forget about getting it exactly here. First, let's focus on getting it as close to this circle as possible, right? After you get close to this, then we can see what you're supposed to do next. First, what you need to do is get this circle with the number of rotations as close to this circle as possible. Now, since you can rotate it, what you can do is essentially, if we rotate this circle by 180 by taking a point, we are traveling the point, this xy point traveled by 2r distance. So with this, what we first understood is, we can use that concept to get this circle as close to this as possible. As close to this, to the point it should touch it. That is our goal. I'll tell you why. Our goal is to make this circle touch this circle. Basically, imagine this is another circle and this has to overlap on it. Okay. Even though this is a circle, this is the exact same circle, but just think of it that way. This has to overlap this thing. So, we should make sure that this circle touches this circle. That's our goal. How do we do it? See, you take this point and this point, right? We need this distance between this, which is D. Let's take it as D. Okay, D. This distance should be minimized as much as possible. How do we minimize this distance? First things first, before we minimize it, we need to find it, right? How do we find it? You know that in coordinate geometry, the distance between 2 points is x minus x dash whole square plus y minus y dash whole square. This is the distance, root. This is the distance between this point and this point. But we need this distance, right? This is r also. So this distance minus 2r will give us this distance. Now, okay, now we know the distance. Okay, this how much. How do you travel it? As I told you, you can completely rotate this circle by taking one point such that it travels 2r distance, right? Our goal is not to find out which point it is. Our goal is not to find out how much, by what angle can we turn it. You don't need to find that. It could be some point, some x equals to 1.62 and y is equals to 6.38. Some point and we rotate it by 12.5 degrees. Doesn't matter. They asked us how many such moves should we do and make it minimum such that this circle becomes his. That's it. For that, in order to get this thing here, you don't care where you put it. You just have to make sure that it travels the distance, 2r distance, and we know that we can put the point anywhere. So we'll put the point and travel it such that it travels this distance. You can put it here. You can essentially put it on the line if you ask me. And you can keep turning this thing. If you turn it, you'll get it here. Then you turn this thing again, you'll get it here. Now, how many times are you supposed to turn it? Because each turn counts as a move, right? Putting it and turning it counts as one move. That is where you do this like this. Since we will travel each and every point by 2r, which means that the point initially and finally will have a distance of 2r, since this is also r, since it will rotate like this. So for each point, for each distance, for each move, we are traveling 2r distance. So for d distance, how many moves will you get? Basically division. Okay. I don't think I had to explain this to you, but since you clicked on the video, I have to. I'm contractually obligated to, or spiritually or morally obligated to, whatever. So this is the number of moves you have to make for this circle to touch it. Sealed. No, I think this is the value for sealed. I don't know exactly. We need to find the upper bound of this one number. Why? Why the upper bound? See, sometimes what will happen is if you get the number as 1.6. If you get the number as 1.6, okay, that means you have to travel. We have to make 1.6 moves, which is not possible. That means one move and one half move. Now you can't make a half move. Okay, so what are you left with? You make one move, and then your circle will be here, just here, so close. If you make 1.6 of a move, then maybe it will touch it. But our point is, if it goes beyond touching, it's alright. It's really weird out of context, but if it goes beyond touching, that's alright. The thing is, if it touches it, that's what we need. We need to touch it. We need the circle to touch the circle, and possibly go through it too. Which also sounds really weird out of context. See, basically my point is, if you make 1.6 as 2, you will go through it. The circle will go through it. Maybe it will come something like this. But at least that is enough. As long as it touches it, that's what we need. So we have to take the upper bound of this value. We take the upper bound of this value, you have, okay. Now, we have brought this circle as close as possible. Now what should we do? Plus 1. That's it. Plus 1. All these things. We calculated this for the distance, how to get close. But for the actual, how to align it. You may be thinking, actually, how is this possible? Like, you have to align this thing. Now, till this point it was easy. You have to just get it close. Now we have to align this thing to fit exactly perfectly. How do you make it in one move? For that, let me explain it to you. So, if you didn't get this thing by this point, look at this picture. This is basically what we'll get, an approximation of what kind of circle representation we'll get after we shifted. That was the answer, right? The shifting part, that you get that, you'll get it here. Now, what does this circle look like? These two circles resemble. Yeah, that's it. But if I had to explain further, basically, this is the point you take as a pivot. Since you already know this thing, you don't need to find out what the point is. It's irrelevant. This is the point. This is the radius. And as long as you take this as the pivot point, the circle will rotate and go here, exactly where you need it. And since putting the pivot point and rotating it will take you 1 unit of like move, it counts as 1 move, yeah, +1. So basically what we had to do was, first things first, make sure we get this thing as close as possible till it touches the circle, the imaginary circle on which this actual circle should overlap. So once it touches it, there is a point we can pivot, and once you can pivot a point, a circle will always move along the point, right, in a circular way, and it will always match that thing. Even if it matches on 2 points or 1 point, if the circle matches on 1 point too, you can just do it, and you get the same circle. So basically, what I had to do was add that thing, and then add 1 to it. That's it. This question was easy. No, I'm not asking you a question. Basically, that was it. An easy question. If you think about it properly and boil down what you need in step-by-step fashion, you'll get it. So yeah, thank you.